I'll just give a quick introduction to Reactor, Tamás. Yeah,
Okay.
ChemAxon's Reactor technology is a library enumeration technology which we think is quite smart in that it uses genetic reaction schema to predict which virtual reactions will go ahead based on a reaction genetic schema that you can edit. And we understand it's particularly relevant to synthetic chemists because they understand about being able to influence the rules in terms of selectivity, exclusivity, and exclude. And you can reach into the reaction set, not with JChem for XL, I don't believe, but certainly with the Reactor GUI, you can reach into the reaction rules themselves and tune them so that, perhaps you run a reaction set, you realize there's rubbish in there, you think about how you would remove that rubbish, and you actually put that into the genetic schema, run again, and if you've removed the junk, or some of the junk, then you have improved the genetic reaction schema, which means every time you run it, you're always going to be benefiting from the improvement in the reaction schema. From ChemAxon's side, we have, I think it's about 150 reaction rules at the moment, and we're very active in developing the rest of the reaction rules. We think there'll be a few hundred, 2, 3 plus 100 reaction rules available to you. The same technology that we run both as the API Reactor and as the GUI for Reactor is available from JChem for XL, but I don't believe at the moment that you have as much, as it were, control there. So that's Reactor, and this is Reactor inside JChem for XL. Back to you, Tamás.
Thanks for introducing Reactor, Alex. So, I'm going to start over with this nice sheet. Here you can see basically a generic reaction in A1. So this is the reaction file. And here, in the A column below them, you can see the reagents, and you can see reagents in the first row as well. So what we are trying to accomplish here is to get a product of all the combinations of these reagents and actually display them in a matrix format. So I'm going to pick the Reactor function from here, which is React product structure. I'm going to pick the reaction from here. I'm going to make it absolute location, as you can use this $sign in Excel. I'm going to pick the first reactants. Here, basically, the A column should be absolute, and the second reactants, oh, I'm sorry, I do it manually. And here, basically, the first row should be absolute. So I enter it like this. And as you can see, in B2, the product of these two reagents based on the generic reaction is displayed. And if you move it to the right, it calculates all the products for you. Let's double click. And here you can see the product results of these, all of these reagents. If you edit the structure here, actually the resulting products are updated. So I enter benzene here. And as you can see, basically all of the resulting products were updated. I will do an undo, redo, and hopefully you can see the changes. Actually, at the moment, there are quite, we introduced all of the features of Reactor inside these functions. So basically, I'm going to demonstrate how to display different products in the reaction, different product variations. And I as Alex mentioned about reactivity and selectivity rules, you can also include them as input information. In the next release, we are trying to give you several examples of using these features of Reactor inside JChem for Excel. But I'm going to show you a demo now about the product variation and displaying different product numbers for a reaction. In this sheet, you can see a very simple one-to-one reaction. It basically adds a chloride. So what's the purpose of this example? This is the input structure in B2. The purpose of the example is to show you that how you can display the different product variations for reaction. So here basically this reaction has got 7 different possible outcomes, and actually the number in the A column is used as the input for this function, actually to tell it which product number to display. And for example, if there is no 8 product variation possibility, it will simply give you not an error message, but it will inform you there is no product for number 8. In the next example, I'm going to show you how to react 3 reagents together and how to display the 2 products of this reaction. So here is the generic reaction again. It has 3 inputs. In the first case, the structures from A, B, and C are the inputs, and in D and E you can see the results of the reaction. So here basically in D it displays the first product, which is given as an input here, and in column E it displays the second product, where it has the number 2 as the input to these functions. As I mentioned, in the future we would like to give you some more advanced and detailed examples how to use these functions, and if you have any feedback about them or how you would like to use them, any improvement ideas, we are very welcome those ideas, because we are thinking about a lot how to include some additional reactor functionality into these functions as well.